Hi everyone, this is section 5.1, the language of functions. I don't think this section is going to give a whole lot of grief to you. For example, this first problem, we're going to complete a table by evaluating this function, f of x equals the quantity of negative 3x minus 2 quantity squared there. So, let me just kind of set this up so you understand what this whole f of x thing is. If you've taken Math 1010 or intermediate algebra or something like that, you've already worked with functions, but some of you might not have. So let me just get set up and kind of explain a couple things for clarification purposes. Give me just a second. All right, I am set up. Let me just pull up a document here. So our function here, f of x equals the quantity of negative 3x minus 2 quantity squared. How this works is if we have an x that's a negative 3, you plug that negative 3 in wherever you see an x. Now, on the left-hand side where you see it says f of x there, that's now becoming an f of negative 3, and that's the only time you really see that. That's just saying, all right, if x is negative 3, what's the answer of your function going to be? Like, what's the y value going to be? It's another way of saying that. So all you do is just plug in that negative 3 in for x. So we're looking at, and notice I got a little notation change. My parentheses here became brackets here because I had to introduce a negative 3 getting multiplied in parentheses inside the brackets there. So it's just order of operations, nesting, grouping, etc., etc. All right, negative 3 times a negative 3 is a positive 9. I still have this negative 2 over here, plus the whole thing squared. 9 minus 2 is 7, so 7 squared there. Your answer is going to be 49. So 49 would be what we would put in right here. All right, and then you would go on to say, all right, if x is 0, what's your answer going to be? If x is 2, what's your answer going to be? And then so on and so forth. All right, hopefully that makes sense to you. And I'll just let that one work for you to figure out. This next one's actually not too bad if you know what to look for. As the number of years decreases from 2 to 1 in the following graph, does the amount increase, decrease, or remain the same? So we're going from 2 to 1. So you have to kind of read this backwards. Here's 2, here's 1. So we're not going this way. Instead, we're going from 2 to 1. All right, 2 to 1. Looks like it's increasing, isn't it? From 2 to 1. So we say it's increasing. If you don't believe me, tough. Just kidding. That's how it works. All right, this next one could be a little bit dicey for you. Let's take a look. You buy a refillable cup from the gas station for $9. They are offering a special where you can buy the cup, and you get soft drink refills for only 30 cents for the entire summer. Write a function that represents the total amount you spend on soft drinks at a gas station for the summer. Be sure to indicate any domain restrictions. Whoa. All right, so we need to write our function first. Near as I can tell, we're talking about a flat cost of 9, right? Like you just buy the cup and then add to that the 30 cents, so 0.30, 0.3, whatever, for every single drink. So x is going to have to represent, write a function x represents the total amount that you spend. Yeah, we're going to let x represent the actual drinks that we buy. So for example, you buy 10 refills. Well, there's the initial charge of $9 for the cup that you buy, and then you have your 10 refills, which you'd multiply that by 0.3, so now you're looking at $3 that you would add to the $9, so you're looking at $12 total. All right, so that's what's happening there. As for this stuff, this is the restriction part. Okay, we're saying for x being greater than, because it needs to be, you're buying more than 0, right? So it's going to be for x greater than 0. I believe that's what we were after here for the domain restriction. That's what this part is the domain restriction. Sometimes it could be less than 0 too. It just depends on the situation. I think that's our answer right there. It likes it. We're moving on. Oh, look at that. I'm not ready to certify. Well, let's continue practice. Actually, I think we got them all, didn't we? Let's take a look and make sure we didn't miss anything. because I've been kind of playing with this over time. Hang on, this isn't, here we go. Yeah, let's take a look at some of these other ones. If the amount is $2,000, what is the time in years according to the graph? That one's pretty easy, I hope. Here's your 2,000. You just go over here and then go down. Your answer will be 1. Okay, yeah, it's that easy. This next one, how long did a baseball travel in the air? Well, here it's launched here at a height of 3 some odd feet, and then it's up in the air for what, 0.9 seconds it looks like, or thereabouts. So 0.9 seconds is what you're after. Is this just an exercise on how well can you read a graph? How long did a football travel in the air? We just did one like that. Graph the given equation by evaluating integer values of x from -2 to 2 and then plot the resulting points. Answer. When you have finished plotting all 5 points, select a button to connect the points and draw the function. Points can be moved by dragging or using the arrow keys. Well, this is interesting. Give me a second. Let me see if I can play with this. All right, I had to do some groundwork on this to get us set up here. So what you want to do is take your integer values and just plug them in. So from -2, -1, 0, 1, and 2, and plug them all into this equation for x. And I did that all over here. The tricky ones, of course, will be the fraction ones. So let's take a look at -1, for example. -1/2 times that -1 minus 4. Negative times a negative will make this a positive 1/2 minus 4. What I did was I turned that 4 into a fraction, 8/2, right? 8/2 is the same thing as 4. So then with fraction subtraction, you just subtract the numerators and leave the denominators the same. 1 minus 8 is -7 there. So -7/2, that's kind of hard to spot when you graph it. That's why I like to turn it into a mixed number instead of an improper fraction. So -3.5 is what we're looking at. And so on and so forth. You do the same for the rest. Now, when you plug them in, I already did the first one. If x is -2, y is -3. Let me take a look at the rest of these. If x is -1, and it's -3.5, excuse me, which puts us right here, correct? And it's going to be linear. If x is 0, y is -4. If it's not linear, then you've screwed something up on this one, because this is the equation of a line. If you had like x squared or absolute value of x or something like that, you no longer have a straight line. You'll have something else, which is a topic for another day. But for right now, this is definitely going to be a line. So if these guys are not in a straight line, then you know you've screwed something up. Let me keep going. If x is 1, y is a -4.5. So here's 1. -4.5 puts me right here. And when x is 2, y is -5. So there's 2, -5, 2, -5 is right there. And then it says, when you finish plotting all points, select the button to connect the points and draw the function. There it is. Submit your answer. That's how you do the problem. This problem is just like a previous one where you write it in function notation. I don't think you're going to run into any problems with this. I'm letting you guys work this one. I don't want to do them all for you. Go ahead and work this one. I think you can run this one okay, but if you get into problems, let me know. This next one, same story. You just plug stuff into the function, find your y values. It shouldn't be bad. This one. As the number of years decreases from 1 to 0, we did one like this one. I'm going to skip that. Same story here. And this one is just like the one we just got done doing. As is this one. I think we're good to go. Yeah, I don't see anything that's going to rock our worlds here. I think you guys should be okay. But if you get hung up, by all means, give me a holler, all right?